So far in this module, that is module 4, we have seen like how the electromagnetic wave is propagating and all, and you have seen that it is getting attenuated. So we have studied about the attenuation constant, phase constant and all. So this is another important area in this during propagation of electromagnetic wave, that is skin depth and the skin effect, and we will see some numerical problems also. Okay, so now let's see. When we talk about skin effect or skin depth particular, the first thing that we talk is, we know that for a good conductor, so we have a defined alpha and beta. So we have derived already what is alpha and beta. So the general expression for alpha is equal to omega into root of mu epsilon by 2 into again root 1 plus sigma by omega epsilon the whole square minus 1. So this is under this root. So all these things we have seen. And similarly, beta, which is the phase constant, is equal to same way we have derived for beta also, which is beta is equal to omega into root of mu epsilon by 2. And the value of alpha and omega varies from medium to medium, right? Lossless, low C, it varies. So my suggestion is you study this expression, and then based on the value of sigma and omega and epsilon, you can change. But so that you need not by heart all the equation. So when we talk about skin depth, we will initially talk about a good conductor. For a good conductor, we know that for a good conductor, sigma is equal to infinity, that is conductivity, epsilon is equal to epsilon naught, and mu is equal to mu 0 into mu r, epsilon naught into epsilon r. Okay, and we have also seen that I have shown you all the 4 conditions. Sigma by omega epsilon is very much greater than 1. So this condition for a good conductor, we will apply that to, for example, good conductor means sometimes they will say the conduction is taking place through copper. They will not say good conductor. If they say it is through copper, that is a good conductor. So this condition you should apply here in alpha and beta, and you will get the updated values of alpha and beta, particularly for a good conductor. So what will be those values? It will be alpha is equal to root of omega mu sigma by 2. So how you are getting in? You are just substituting the values here. So since omega by epsilon is very much greater than 1, this particular 1 and this particular 1 can be neglected. Then it will be root of sigma by omega epsilon, which is again equal to sigma by epsilon. Then epsilon you can cancel. So all these things you can do. Then it will be simplified to omega mu sigma by 2. And you know that omega you can write 2 pi f. So that also you can substitute here, because sometime in your question paper, they will be giving you frequency. In that case, it will go like pi f mu sigma. 2 and 2 will get cancelled. Similarly, beta also same way, same on similar terms. When applied to this equation, you will get how it is different, how it is varying. You can understand from there. So what you will get is, okay, so for beta it is plus, right? Beta means it is plus, right? You're not correcting. So pi omega, and similarly beta also you will get the same expression. So plus 1 or minus 1, that doesn't matter when sigma by omega epsilon is very much greater than 1. So that can also be neglected. So for same value you will get for beta also. Okay, and then the velocity u can be written as omega by beta. So that will be again updated to root of 2 omega by mu sigma. That is from this equation. From this equation, when you substitute it here, you will get like root of 2 omega by mu sigma, and intrinsic impedance can be written as root of j omega mu by sigma. There is in the same equation, intrinsic impedance can be written as root of j omega mu by sigma. So This is equal to root of omega mu by sigma angle 45. So how you got that? So we have a big expression for intrinsic impedance. So from that you can directly write here. What was the big expression for intrinsic impedance? Is equal to, what was it? Sigma omega by, so in that when you substitute, you get. So eta is equal to j omega mu divided by root of, yeah, that also is known, root of j omega mu divided by sigma plus j omega epsilon, right? So in that same equation, when you apply the condition for a good conductor, that eta value also will get updated. So you will get it like j omega mu by sigma and the root of omega mu by sigma, and angle will be 45 because of the root. So this is the magnitude, and angle will be 45 because of the root concept. So that is actually mathematics. So you just understand that it will be 45. Okay, now what we want to understand is skin depth, right? So from this equation, since it is 45 degree, and you also know that by theoretical expression, eta is equal to E by H, right? Eta is equal to E by H. We have already seen that. That means, since this is 45 degree, we can say that electric field E leads H by 45 degree. Then we can write E is equal to E naught into E raised to minus alpha Z into cos of omega t minus beta Z AX. So this is the electric field of the electromagnetic field. And then you know that there will be a perpendicular magnetic field, which will be along the y direction. So we can write in terms of magnetic field can be written in terms of electric field. Only thing is you need to divide that with the intrinsic impedance. So E naught divided by eta. So for eta I am writing root of omega mu by sigma into e raised to minus alpha Z into cos of omega t minus beta Z minus 45 degree along AY. So just understanding. So this is for a good conductor. So what we can see, as E and H travel in a conducting medium. So we understood that as E and H travel in a conducting medium, its amplitude is being attenuated. Its amplitude is getting attenuated. So this thing also I have explained to you how it is getting attenuated. There is a factor of e raised to minus alpha, right? By a factor e raised to minus alpha Z. So the wave which is propagating along the Z axis, which has the electric field along X direction and magnetic field along the Y direction, is getting attenuated by a factor of e raised to minus alpha Z, even though it is a good conductor with sigma is equal to infinity. So now, what is skin depth? So we understood that the wave is propagating for a good conductor, the values will be updated like this. This efficient eta intrinsic impedance will be this value, alpha will be this value, beta is this value, then the velocity of which with the speed is propagating, that will be omega by beta. That also we understood. But the question is, what is skin depth? So in order to explain skin depth, what we can do is, so let's consider the wave is propagating and its amplitude is slightly rotating, right? So this is how the wave is propagating, and this is the idea. And then this is 0, and this is the attenuated amplitude, which is 0.368 of E naught. So this is the electric field that we are talking about. And this value is what we call delta, and that is the skin depth. So this value is delta, and we call that as skin depth. So we can explain it like the distance delta. The distance delta through which the wave amplitude decrease to a factor e raised to minus 1, that is e raised to minus 1 by e. If you see in your calculator, it will be about 37% of original value. That's why 0.368. So next semester, when you study control system, you will understand in detail about these things. Okay, this is a fact. This graphical things and all is called skin depth. So the distance through which the wave should travel, so that the amplitude is 37% of the original value. That is, it is getting reduced by a factor of e raised to minus 1. That is 1 by e. It is called skin depth or penetration depth. Skin depth or penetration depth. So when a question comes, what is skin depth? You should initially write a wave is propagating along the Z direction. Then if you're talking about a good conductor, then this will be the values. It will have an electric field which is along the X direction, magnetic field along the Y direction. They are mutually perpendicular. They are 45-degree phase shifted. All these things you should write. And then you should come to the point that it is getting reduced by a factor. The amplitude is getting reduced by a factor of 1 by e when the wave travels a distance of delta, and that delta is what we call skin depth or skin penetration depth. So we can say skin depth is a measure of skin depth is a measure of skin depth is a measure of the depth to which is the measure of the depth to which an electromagnetic wave penetrates the medium. And the phenomenon by which the field intensity in a conductor rapidly decreases is called skin effect. Okay, the phenomenon by which the field intensity in a conductor rapidly decrease is called skin effect. So very simple thing, but you should write down the story, draw the diagram. Yeah, so there should be a better way of presenting the answer. So if a question comes, what is skin depth? Just don't simply write a small statement like wave is getting. So you should write the points, you should write the diagram, you should like valid points you should write. Okay, so that's why I'm telling all these things in detail, even though these are all simple areas. So just like that. Okay, now we will do one question. So we understood that skin depth is the distance that the wave is traveling. So you know that the wave is propagating. So this will be the equation like E0 e raised to minus alpha into delta. Like Z will become delta value, right? This distance is delta. So that is equal to E0 into e raised to minus 1. So we can say delta is equal to 1 by alpha. So this value of skin depth. So if you are asked to calculate skin depth, the equation is delta is equal to 1 by alpha, or you can even write delta is equal to 1 by alpha is equal to 1 by root of pi f mu sigma, because alpha value we have calculated. So that is the expression, very important. So based on using this expression only, we are doing all our problems. So equation of, because in module 4, all the equations will be direct, but there are a lot of equations. So that's why I told you to study the basic equation of alpha and beta and give the conditions. We will do similar problems. Then it will be easy for you. Now we will solve this problem. So how we will solve this? We are asked to find out delta. So what is the equation for delta? We have just seen delta is equal to 1 by root of pi f mu sigma. So this question can come in your A part, a very simple question. So, but be careful about the units when you substitute. Yeah, so that is very important. So pi into, so frequency is not 50 hertz. When you see frequency, don't go directly and substitute 50. Here it is 30. It is not a sinusoidal frequency we are talking about. 30 into 10 raised to 6 into, then mu is equal to mu 0 into mu r, right? So mu r is equal to 1, it is given, and mu 0 is 4 pi into 10 raised to minus 7 into sigma. So that is 5.8 into 10 raised to 7. So this is very simple. The answer that you should get is, you should calculate, because in exam you are the one who are doing this problem. So you should calculate 1.21 into 10 raised to minus 5 meter is the answer. So just check and verify whether you are getting the answer or not. Okay, then we will do another problem. So the question is, okay, so this problem also we will solve. So it's all about direct substitution. So first of all, we will find out the intrinsic impedance. So I will go with the basic equation. So you know the intrinsic impedance. So just by heart this equation, j omega mu by sigma plus j omega epsilon. So they are talking about copper. So copper is a good conductor, right? Copper wire is a good conductor. Then you can, so you good conductor property you already know, so I'm not going to write everything here. So it will be root of j omega mu by sigma, because for good conductor sigma by omega epsilon is very much greater than 1. Okay, then it will be root of omega mu by sigma, and you know that j, what does j mean? J is 1 angle 90. So root of j, what it will be? Root of j, root of 1 is 1 itself, but angle will become half. 1 angle 45 degree. So this is 45 degree. So now we will calculate eta, which is the intrinsic impedance. So eta will be, eta is equal to root of omega will be 2 into pi into, so are they giving the frequency? 2 into pi into 1 megahertz. So 1 into 10 raised to 6 into 1 divided by 5.8 into 10 raised to 7 angle 45. So it is not under root, 45 degree. So it is 3.69. Calculate all these things by on your own. Okay, 45 degree ohm, and beta also you know, just a phase constant, omega into root of mu epsilon by 2 root of 1 plus sigma by omega epsilon the whole square. One should be inside. Sigma by omega epsilon the whole square plus 1. And you know that for a good conductor, sigma by omega epsilon is greater than 1. That means you can write root of the same expression, omega mu sigma by 2. So now you substitute everything here, 2 pi into 10 raised to 6 into 1 into 4 pi into 10 raised to minus 6 into 5.8 into 10 raised to 7 divided by 2. That is equal to 1.513 into 10 raised to 4 radian per meter. And one more thing they have asked, phase velocity. So phase velocity expression is, so this is the expression for alpha also. For a good conductor, beta is equal to alpha, right? And what will be phase velocity? Phase velocity is V is equal to omega by beta. So that also you can calculate. Omega is 2 pi into 10 raised to 6. How 2 pi into 10 raised to 2 pi into frequency. Frequency is 1 megahertz by beta. Beta value you know. 3 into 10 raised to 4. So that is speed is 415.2 meter per second. So this is also very simple. So these are the type of problems that they usually ask in from these modules. So you should know the equation, what type of material it is. So we have a question. The electric field also. So this is not the question directly. So I'm overall questions only I'm doing here. So the electric field associated with a plane wave traveling in a perfect dielectric medium is given by this equation 10 cos volt per meter. Find it is propagating along z direction. So you know minus 0.0 beta z means what is it? Minus means it is propagating along the plus z direction. We have studied that. Okay. Find the velocity of propagation, and the expression for the magnetic field intensity is mu is equal to mu naught. That is the question. Okay, let's see. We have the equation E of Z comma T is equal to 10 cos 2 pi into 10 raised to 7 T minus 0.5. So this is given as 0.5 is a volt per meter. So you know the general expression. It is A cos omega T minus beta Z, right? So what does negative mean? Propagate along, the propagation is along positive Z direction, right? So one by one, the steps we are analyzing. So it's along positive Z direction, and you know that omega is equal to 2 pi f. So you can write 2 pi into 10 raised to 7. And beta is given as 0.5. So they are given 0.5, that expression. Then we can write V, the velocity is omega by beta, that is equal to 2 pi into 10 raised to 7 by 0.5. So the speed is 2 into 10 raised to 8 meter per second. Then eta can be written as eta is equal to root of mu by epsilon. So eta is equal to root of j omega mu. So how you got mu by epsilon? I am telling you, j omega mu by sigma plus j omega epsilon. So you know that for dielectric medium. So here they are talking about dielectric. So sigma is equal to 0 for them. And also V is equal to 1 by root of mu 0 mu r into epsilon 0 into epsilon r. So that is equal to 1 by root of mu 0 into 1 into epsilon 0 into epsilon r. Because for free space also you can say mu r is equal to epsilon r is equal to 1. So we can write V is equal to, so this expression 1 by mu naught C naught can be written as C, right? C is equal to 1 by root of mu naught epsilon naught, we have seen, which makes the expression V is equal to C by root of epsilon R. So all these equations you know. So the idea is you should have the mindset to apply these equations on our convenience, right? Epsilon R. Then we can write root of epsilon r is equal to c by v. So we have the value. So c is the speed of light, you know, 3 into 10 raised to 8 by v is the phase velocities, that is equal to 1.5. And also we know that, so eta is equal to root of mu by epsilon. We have seen from the expression we have obtained. Then it will be root of mu naught into mu r by epsilon 0 into epsilon r. Root of mu and epsilon are two terms that we know the value, right? So root of mu naught by root of epsilon naught can be, we can substitute the value. We know 8.854, you know the values. So that we can obtain as 120 pi. So these shortcuts you have in your mind, okay, when you do the problem. So it will be more easy for you. So which makes it 120 pi into root of mu r is equal to 1 by epsilon r. So root of epsilon r we have already obtained. So 120 pi by 1.5. So which is equal to 80 pi. So we have obtained eta as 80 pi. So we had the expression of electric field. We obtained eta. So then what we can do? We can obtain magnetic field. So what you should keep in mind here, electric field is given as 10 cos 2 pi into 10 raised to minus 70 minus 4. So we have obtained electric field. So similarly, we should obtain the magnetic field. That's it. So magnetic field will be electric field divided by eta. So Hy is equal to E by eta. This is equal to 10 cos 80 pi 2 pi into 10 raised to 70 minus 0.5. So you can cancel, and final answer is 1 by 8 pi cos of 2 pi into 10 raised to 70 minus 0.27. So this is the final answer that you should obtain. So you can see that it's all about direct substitution, but you should know the concept. That's it. Then you can score good full marks in this module. I want everyone to score full marks in this module. Okay, so I hope this is clear for you.